of association of several animal flock and management factors with Scotty in Irish sheep flock. So this is the title of the study. And again, if you want to look at the whole document, then you can Google that one. So what it says is the characteristics of 61 sheep flocks with at least one laboratory confirmed case of scurvy. During this period were compared to 61 flocks with no history of scurvy. And again, these are matched by geographical location and attending veterinary surgeon. So that means except the presence or absence of scurvy, other conditions are the same in these two group of flocks. So this is about what the study was. The detailed 7-page questionnaire was sent to the participants in both groups, those with positive and negative flock. So these are the information they gathered. Area of farm, that is geographic location, flock characteristics, the placement policy, breeding management, sales policy, and several other stuff. As I said, it was the 7-page questionnaire. But for us, because we are just limited to 2x2 table, I just picked one of those variables, ways of disposal of placenta. So that is. Again, if you look at the whole paper, this is the only one which shows significant relationship. So that's why I picked this one. Again, as I said, we also limit ourselves to just 2x2 table. That is one exposure and one outcome. So this is the data. In 47 of the scurvy positive farms, placenta was not recovered or was made into the compost. Then this figure was only 36 for the scurvy negative farm. So the rest is the question. What type of study this and why? I'm sure this one you can answer it without drawing our 2x2 table. What type of study is this and why? Case control, why?
You're looking at exposure and outcome. Disease, not diseased.
Yes, that is your starting point. You start with cases and controls of cases and non-cases. So that's what we do in case control studies. In cohort, as you know, we start with what?
Exposure.
Exposure, exposed and non-exposed, and then we follow them to ascertain whether the outcome develops or not. And in case control, it's really opposite reversal. So we start with cases and then look back into factors that may have led to the disease. And again, B is also important. What was the case definition?
Sheep flocks with scraping.
At least, yes, at least one confirmed case. So flock with at least one confirmed case. So it can be the whole flock, but what you are looking at is at least one sheep is infected from that flock, then the whole flock is considered as a positive flock. What is the exposure factor? What is our risk factor here? Yes, it's ways of disposal for placenta. So when it's not recovered, we call that one exposed. When it's recovered, then we call that one non-exposed because it's removed. Then it says, construct a 2x2 table and calculate the appropriate measure of association. What's our appropriate measure of association here? Pardon? Odds ratio, yes. So in case control, we always our measure of association in case control is always odds ratio. So as you said, we start with scurvy. So that is, then you can put whatever you want, positive if you want, and then the other one is negative. So you know what positive is and what negative is. So again, it's not at animal level, this is at what? At the flock level. So positive flock means, or scurvy positive means flock with what? At least one confirmed case of scurvy. When say negative, the scurvy was not detected in that flock in that 10-year period. Again, I think let me So this is our, again, I'm just making it simple. So placenta here, not disposed, because that is what we consider a risk if the placenta is not disposed. And the other one is removed, or we call it disposed. Not disposed means not removed or made into compost or left in the grazing field. Then disposed means removed, or then after that it may be incinerated or buried. So according to the data that information that was given, both farms, what is the number of the farms?
61.
Scrapie positive farm is 61. Negative farm is also 61. So this is, they match them 1 to 1. Flock positive and flock negative, they match them 1 to 1. So here, from this, in the Scrapie positive farms, placenta was not removed in 47 of the cases. Then the difference always is what? The difference is where the placenta was removed. In the same way, this number was only 36 for farm, for a Scrapie negative farm. So again, the difference will be those where placenta was removed. So it's 61 of Scrapie positive farm. 47 of 61 Scrapie positive farm, placenta was not disposed. And then this figure was what? 36 for Scrapie negative farm. So the rest is just the difference, because we need those values in order to calculate odds ratio. So what is our odds ratio here now? Odds ratio equals what? It's,
A
as you said,
multiplied by
it's
T,
really very simple to calculate.
C multiplied B.
It is very simple to calculate. So it's AD divided by ABC. Let me merge this one as well again. Which is equal to 47 times 25. You multiply them across. So it's, as you said, it's cross product ratio. It's cross product ratio. Then you divide this one by 36 times 14. So do you have any figure for this? How much is it?
2.3.
Pardon?
2.3.
2.3. Then what is, can someone make sense out of this?
There's a 2.3.
It is 2.3 times more likely that if you did not recover the placenta, you will get scrapie.
That is the ultimate result. But the what you call extrapolation. But let's just focus on this figure, on this number. Ultimately, when we calculate odds ratio, really it is because it's retrospective. You really cannot calculate risk for this data. So you are estimating the risk based on odds ratio. So odds ratio will give you an estimate of the risk. So there is nothing wrong with what you say. But this is based on odds, so let's interpret it based on the odds.
Because it is more than one, so there is association of having a...
Yes, again, that is really very general. I really want it very specific. Yes, you try? You want to try?
Well, what I was going to say was kind of...
Start with odds, then you will get it. Start with odds.
Start with what?
Odds. Because we calculate odds ratio. Remember, we calculate risk ratio, we said the risk of disease is this much. Now start with odds and then go ahead.
So, are you saying, the odds of an animal getting scrapie would... I don't know.
Well, again, always look at what you are assessing. In this case, the disease you really pick them based on, any condition, based on, we said, attending veterinarian and geographic location. You pick those infected farms, and then you match them with controls. You intentionally, according to data, they match them 1-to-1. You really can't say a lot about disease. But what you are looking at whether exposure is differentially present in scrapie positive farms compared to scrapie negative farms. So your inference is really about exposure now, because the disease and non-disease, you selected them, you chose them. You know what I'm saying? So the interpretation that to make is really about the exposure. Is the exposure more common in scrapie positive farms compared to scrapie negative farms? So your conclusion is really about the exposure, yes. And did you get my point?
So we can say that 2.3 is likely to be having exposure, more exposure as compared to those. We can say like it.
Yes. Okay. Right. Yes. That's the idea. But you really have to. Go ahead.
So would you interpret it, like, would you say the odds of having a scrapie positive farm depends on how the placenta was?
Definitely, yes. Yeah. That's what you have to say. But you, as I said, you have to use this number. So let me just say, it's the odds of now not removing placenta. The odds of not removing placenta is 2.3 times higher in scrapie positive farms than scrapie negative farms. So your conclusion is about not removing placenta. The odds of not removing placenta. The odds of not removing placenta is 2.3 times greater in scrapie positive farms compared to scrapie negative farms. Yes?
So why would you, and then you just said it's 2.3 times likely to not remove the placenta in scrapie positive farms.
That's perfect.
But why can't you say it's 2.3 times more likely to have scrapie virus if you don't remove the placenta? Because there you just reverse the two factors to make one dependent.
Say it again. Say it again.
I don't even know. Never mind.
Say it. But I have no problem with your idea. That's
so your factor there was saying, so we have A and B, and you said it's 2.3 times more likely to have placenta exposure in scrapies positive farms. So your A was placenta exposure, and your B was scrapies positive farms.
Yeah.
So why won't you flip those to make it more sense? Where you have it's 2.3 times more likely in positive scrapies farms to not remove the placenta. You see what I'm saying? Does that make sense?
No, it makes sense. But again, what I'm emphasizing is, in this case, you have the cases and controls. Those one really you can't say much about them because you chose your cases based on what you can control. In this case, for instance, you mark them by attending veterinarian, you mark them by geographic location. So you can't compare something around the city with something around Lee County or out of D. So you mark them based on that. So based on the cases, now you chose your control. You know what I'm saying? So you really can't say anything about this disease in one group and the other. What you are talking about is what? About its exposure is really differently present in these two groups. So when I say placenta is 2.3 times not removed in scrapie positive farm than scrapie positive negative farm, your conclusion is about placenta, because that's what you are assessing. Is placenta or is exposure more prevalent in disease than in non-disease? So ultimately, because this is an estimate of risk, that's what your conclusion is. So here, probably not removing placenta is associated with scrapie positive scrapie. That's ultimately the end result. But when you are making conclusion, it is really what you are assessing. You are assessing exposure, so you make conclusion about exposure. Yes?
So in a sense, is it kind of like independent variables and dependent variables? Like in this case, the scrapie would have been our dependent variable, or
No, independent.
it'd be the independent
Yeah,
variable,
independent variable.
and then
Exposure, yeah.
exposure would be the
Sure,
dependent.
yeah.
So you're saying that
Where did you put it? Please,
seeing
it's always gonna be
recovered or seeing not recovered placenta depends on if that flock had scrapie.
Because of the arrangement of the design, yes, because of
Okay.
the design, yes.
Even in the
yeah.
auditorium,
Yeah.
even in the auditorium.
Any question? So, when you calculate the risk, I remember because we already know the exposure, you already know the exposure, we say about what? The risk of developing disease is 3, this is now risk ratio, we say the risk of developing disease is what? 2 times 3 times higher, 2.3 times higher in exposed group compared to non-exposed group. But this one is odds, the odds of not removing placenta, because that is what we are assessing. We are ascertaining whether placenta is differentially removed in those farms, positive and negative farms. So the odds of not removing placenta is 2.3 times higher in positive farms compared to negative farms. But again, at the end of the day, your decision will be what? You say that there is more risk of scrapie when placenta is not removed. So that is the conclusion. And after that, as you said, because this is not a very robust method, what people normally do is what they design some kind of cohort study now and follow whether, or experimental study and follow whether this association is some or one of causal and cause and effect.
So in other words, odds ratio is a prediction, future prediction that
Definitely,
this is
yeah.
not a result actually. You are predicting that how much it could cause, likely to be happen. That's the
Yeah,
question.
sometimes when we are designing cohort study and we'll start experimental study very soon, those are really very costly because you have to follow, if cohort study, you have to follow them for 10 years, for 5 years, that really costs money. So you really can't just start out of the blue. With case control study now, where you just collect the data, you just screen them. Now they have what? Several risk factors here. The one that said positive association were very few. One of them probably is only this ways of placenta disposal. So now you have identified these. Now you design robustly now to study this one. You can spend money and your time in establishing association with this one. So case control study is like really a fishing expedition. You look at several risk factors, and then finally come down with the ones that show significant association, and then based on that you just focus after that on those associations that were significant.
Just because the case study is a longitudinal studies, so the cases might be disappear in between or they can come in between, so that you cannot predict the right answer. So that's why you do odds ratio. That's the reason.
It's really because of cost and time when you do case control study. And you really, for example, in this case, how they looked at how many conditions. Look, a detailed 7-page questionnaire was sent to the participants in both groups. Information was sought on the areas of farm and flow characteristics, replacement policy, breeding management, sales policy, management. So you have to design what? Cohort study for all these variables. Okay? With some of which are not associated with what? With this scraping. So it's just wastage of money. So by this you screen and come up with what? With associations that are significant. After that you design your what? Your cohort study or experimental study. Is it clear? Is it clear, guys? No? Okay, now let's start with the last part of our design, which is experimental studies. In experimental studies, they are also called trials. They investigate the role of some factors or agents in preventing or whether they prevent or cure disease. So that's what experimental studies are. The role of some agent or factors in prevention or treatment of disease. So in this design, individuals are assigned to 2 or more groups. So that is how experimental studies are designed. Study subjects are assigned to 2 or more groups. One group will receive the preventive or therapeutic agent, and the other group do not receive the therapeutic or treatment or preventive agent. The group receiving the agent is treatment group. The other group, which is not allocated the agent, is control group or comparison group. So you have 2 groups, treatment groups, comparison groups. So this comparison group may not receive anything. Sometimes they just give them a sham substance which looks like treatment. Sometimes if you have existing treatment, then you may also give active treatment compared to the new one. So the hallmark of experimental studies is what? Active manipulation of the factor by the investigator. In observational study, the investigator doesn't what? Really doesn't involve or involved in the assignment of the agent. That means it just observes what is happening.